Iguaçu, and today I need to another conference in Foz do Iguaçu, yes. I'm from South in Curitiba, and right now I needed to go to Brasilia to another conference, but I'd like to share some experience with you and what I do in practice using complex networks. I'm a PhD student, and in fact, I don't study complex networks. My field of research is in tattoo recognition. It's another field. It's because tattoo is like a biometrics recognition. But today I'd like to talk about what I do in my company, in my work. And I work with criminal analysis. And we use complex networks in criminal analysis to use in avoid fraud, corruption, money laundering, and other things. And is what I start to talk about. I try to organize my ideas here. I start with the applications, and after that I will show some different research, little research that I did in complex networks. So let's start talking about applications of complex networks in criminal analysis. The problem is that every time we are studying complex networks, very complex. We have a lot of studies, a lot of research in complex network, and when we try to translate it to criminal analysis, for example, we are talking with people who don't know how to use technology. And in fact, they don't know how to use or how to apply the complexity of complex networks in real cases. So our challenge is try to translate it in a little bit more simple tools and apply it in real investigation. For example, so Caseboard is the software what we developed. We are a Brazilian company in South Brazil, Curitiba, and the Caseboard is what we developed. Is basic a data analysis platform composed by more than 20 different tools, and one of them is the link analysis. We call complex networks in different ways in different fields. Like in criminal analysis, we call it link analysis. It's more simple to understand. And how we do that? We need to use complex network to show real connections in criminal analysis, in fraud analysis, money laundering analysis, and help people to understand the connections and help people or investigators to understand and make decisions based in information of criminals. I will show some examples. This is a complex network, but sometimes we need to cross information in CDR files to understand communications, call communications, telephone call communications, understand who talks with who, and how the information flows between all person or all people that are investigating. So we need to cross and understand who is the main persons, where starts the communication, where finish the communication, and we try or we use a complex network to show how the communications were. So in the same way, we can cross information in transactions, financial transactions, and understand how people send and receive money, or blockchain, and no matter what kind of transactions they are doing. So we can use complex networks to understand the networks in financial transactions. Other applications. Understand how people use their credit cards. Or sometimes we have frauds involving credit cards, and we need to understand how people use the credit cards, where all times, what kind of the technology they are using, IPs, devices. So we use complex networks to show all communications, all uses of credit cards, for example, all the machines, people, etc., to try to understand who is the main people, the criminals, the locals, etc., and see it in practice. One more, cross-information in social networks. Sometimes we need to discover how people interact with each other and who knows who. And we can collect a lot of information based in social networks, open information in Twitter, Facebook, no matter where, and we can use the networks to understand who knows who or who interacts with who. This is another one, using complex networks to show interaction in social medias. Also, when we need to understand where people use the TBS. TBS is the towers, cell phone towers, and also we can cross information of cell phones, towers, to understand where people were when they were using their cell phones. In prisons and other places, or when we need to understand if somebody was there or not, we can cross information with different kind of information together. Also, we can create and monitor information of criminal groups like PCC and others, and understand who is connected with who, and understand the interactions between the leaders of the organization, the people who is just selling drugs or passing information through others, so we can manage and organize all information about people using complex networks. And sometimes we need to, this is the first thing what we do. But the next step or the next challenge is how to use different applications of different uses of complex networks, not only to show the information, but also to help to understand what's happening in the information. So we can apply metrics, centralities, homophily, link prediction, community detection, click detection, central core and periphery. So every time we need to learn more about complex networks and try to translate it to a real use in criminal analysis. So this is what we do. And this is why I'm here. Just to learn more about the complex network, what people are talking about, and how to get more in the modern algorithms and try to translate it in practice to criminal analysis. So let's see some examples here. The metrics to try to understand the density, median degree, and other things. Sometimes we need to compare two different graphs and understand how different they are, so we can use metrics. This is the centralities. Of course, we have tens of centralities, and this is a very challenging task because we need to understand how to how to show the main nodes here, but try to understand what it means in the practice. For example, when I use a centrality in a communication, we have people in prisons, and we are trying to understand who talks with who. And when we use different centralities like betweenness, we can understand where we can cut the communication. to stop the communication. So we can identify who is the main persons and try to cut the communication to stop to flow the information. The same when we are talking about financial transactions. We can understand using centralities, where is the core accounts, who is receiving more money, who is passing more money. So we can use different centralities measures to understand and like know exactly how to act to stop the flow of money. So this is what we do. This is not simple. Of course, when I'm talking to you, you can understand it's very simple, but when we are talking with the policemen, wow, it's a good challenge. And is that what we do. The same when we use the field informations using homophily to understand and organizing by using colors to know more about the communication, the kind of the type of communication, the type of the people here. We can use another information like homophily to classify the information. Also, sometimes we need to guess who is not linked but could be linked. So we use some strategies to link prediction to understand in complex networks. Sometimes we don't have, sometimes the most of time we don't have all information. So we need to understand the probability of two people are connected, but they are not connected. So we need to try to understand or try to guess who possible would be connected. So we use some strategies of link prediction. Of course, clustering. I will show an application of clustering, but sometimes we need to organize people, understand by using clustering how to separate in groups. So we can use clustering to organize information. Also, a very interesting application of click detection. And I like this application because sometimes we need to analyze mobile extractions. And we get maybe sometimes 2, 3, 10 different extractions of cell phones. And we need to cross in forensic analysis, understand what information is good to make decision. And one kind of information that we cross here using complex networks is faces in photos. So we can extract information of hundreds of thousands images inside of cell phones and get all information of faces in photos. And every time we have more than 2 people at the same photo, we can create a link between them. So we can automatically translate thousands or hundreds of thousands of files in a complex network based in relationship of the faces inside the photos. And when we need to know who is, there is photos with a lot of people or many people, or sometimes I need to understand, Rodrigo knows another people, so we need to use click detection, for example, to get parts of the network where we have a group fully connected. And we can understand that those people was found at the same photo, the same of those group, that group and that group, because everybody is connected because probably there is a photo where everybody is together at the same photo. So we need to, like a data miner, using complex networks to show the results. And another one, central core and peripheries, another kind of try to organize and show in different way uh, the core people or the core edges, understand who is the top, who is around the top, and etc. All right, this is the first part. What I do or what we do in practice. How to translate in a simple way for people who knows the theory about the complex networks, and how to make it simple, simple, to use it in day-by-day tasks, in investigations. All right. Let's talk about the two different applications. This is one I did in a chair of complex networks at the university. How to understand political networks and coalitions in electoral. I don't know if you know, but in Brazil currently we have 32 political parties. And every time we ask, why 32? It's a lot. We don't need that. Everybody knows. Yeah, but yeah. Exactly. It's like to make confusing the process in practice. Yeah, we have a very spectrous, extreme left, center, center right, extreme right, etc. But the problem is, what happens in the period of elections? Coalitions, you know? So when we start the time of elections, everybody starts collisions. They start to work together. In the last one was Lula with device? Alckmin. I grew up understand that they are working separated, but I don't know. Today they are together. I'm not saying that that is good or not, or bad. Just happen, all right? And what we did here is get a database from TSA and try to understand how works in the last four elections, federal elections, organize the parties, the coalitions, the total of candidates, and after that, try to understand the winners at the same way. So what we did is create complex network to understand the parties, the coalitions, the coalitions, and how they start to work together. And after that, using community analysis, given Neumann, Louvain, and centralities like betweenness and PageRank, understand how it works in practice. So the initial networks in 2010, when we organize all the coalitions, we have a network like this, where everybody is together in a way, or almost everybody. There are one or two that separated. And when we analyze the elected people, they continue together because the coalitions. And the same in 2014, 18, the numbers is growing. In 2002, we have a compression. And once we have everybody or most of people connected in a way, in coalitions, we try to understand who is the main persons. understanding centralities, the influence. So we have the parties, PMDB, PP, PTB, PT, them. It's just exercise to try to understand how people or how the politicians play this game. It's not a deeply study, but just a study to try to understand it and try to show that sometimes people are working together. In fact, they are working together in a specific way, I don't know. And the same in 2014, 18, 22. And when we have an election of Lula, the PT is the #1 because they have more influence and maybe more people working together. And we can see the other parties at the time. And this is a little bit interesting because once everybody or almost everybody is working together or they are connected, what happens if we use a clustering to understand it? We can see that maybe, in fact, probably we don't need 32 parties because we can divide them in 6 or 8 or maybe 10 different colors or different groups. And the same occur in 2014, 18, 22. So it's a simple way to show and try to understand how people organize in groups when they need to work together, for example. That is not a complete work or study because we are not using, for example, performing votes, the switching of parties because people switch and change of the party. And of course, we have more variables about correlation between them, information about the proposes. We don't use the proposes, how they can cross based in propose that everyone proposed it in candidatures. So this is another application, how to use complex networks. And the last one, it's another work I did using a view of link prediction using graph neural networks. It's a challenge when we talk about link prediction, because in practice we don't know if it really happens or not. We are just try to guess if it's true or not, especially when we apply in practice this. For example, I'm trying with a crime organization, and I have a map with everybody connected, and I try to understand or try to know or try to guess why people is not connected. And in fact, I don't know if they are or not, but I just looking for some clues to understand and make decision. Right? So this approach is based in graph neural networks, and I use some networks. Basically, the problem is we have a network, and we need to try to predict or get some ranking. The probability, it's not exactly a probability, but it's a simple way to explain. The probability of a pairwise that is not connected be connected in real world. So there's a lot of approaches in link prediction, and what to use it is a classifier-based methods. And basic in graph neural networks, we have a lot of inputs. I will show later. We have some hidden layers and an output, and try to learn based in topology. Yes. All right. I'm there. Try to understand and predict how each pairwise is connected or not. So we use a network in Bedies, following the same idea. The word to vec is used to understand the language. So we have phrases divided in parts of phrases, create embeddings, and after that try to rebuild the complete phrases. And we use the same idea to graphs here. So to train, you use the known networks like Colligan, Scora, PB datasets, Power, US Power Grid, US Airlines, East, and other based in call phones and financial transactions. And as a result, we can see that we can create neural networks or graph neural networks with the capability to predict. I don't like the predicted term because it's good, but we need to try to see in practice when we don't have all information available, how to predict connections that we don't have information, and try to act or try to get more information. For example, when we are working with cell phone communication, if we understand that these people that have high probability to be connected, we have more information to get and ask for more information in telecom to the dude. So we need just to have basic information to get more information to until the final decision. And we tested in cell phone communication, financial communication, and of course there's a lot of different scenarios in future work, but this studies to try to applicate a different way and a different approach in link prediction. So that's what I do. That's why I'm here. Thank you for our time. Thank you for share all your experience. I'm very thankful to be here. It's my first time between the physicians. Thank you very much.
Thank you a lot, but we have physicists.
Physicists, thank you, I'm sorry.
Allora, so, question time. 1, 2, 3.
All right.
1.
Can you hear me?
Yes.
Okay. So, thank you for your presentation. Just a quick question about how you build the data set. So you have like calls,
Uh-huh.
calls that you go and then apply to the graph neural network. And normally those data sets are like, they have annotations from experts.
Mm-hmm.
Elaborate a little bit on how you do that?
Yeah, when we train the data set, we get known networks, and we broke in small pieces to create the embeddings. So we have annotated database, and we know where we can go, and we use this approach to understand and to train a graph neural network.
Just another
Short question, short answer, because we have many online. Please.
Just a very short question out of curiosity then. It's the same data set that you used on the other on your other work on the trying to analyze how the connections between criminal activity works, or it's another data set entirely?
I'm sorry.
Is it another data set from the first work that you presented on criminal analysis, or is it like a intermediate?
Yeah, we have a lot of data sets because
If it is the same data set or it's a different one.
different one.
Different.
Different one, yes.
Second question was, I don't remember, you.
Hi, I'll just do one question. for people that don't know, we are in a bit of a situation here in Brazil, a political scandal. Have you tried applying your methods for the criminal data analysis to the Bolsonaro case of the scandal that's going on nowadays, or other high-profile cases? Or,
I know. No, I don't.
but probably.
Yeah, but I know people that are using in these cases, but in my company, no.
No, okay.
I don't have any cases of analysis of this.
Might be interesting.
Yeah, it's very interesting because there are a huge amount of information to cross in different ways, in different kind of type of information.
Other questions? You. Just a moment. Take this.
I think it's because you said you studied the PCC network. Do you have this kind of network?
Yes, but no.
Yes, but no.
Okay. Another question, short question. Did you think in study federation instead of just coalitions? Because I think since 2022 we've had federations between parties, not the same thing that coalitions.
I'm sorry.
You consider federations instead of coalitions? Between parties.
I don't know.
Because we have in Brazil coalition,
Yes.
but we have since I think 2022 we've had between parties federations as a different target.
Yeah, but I think
It-
that his data are up to 2022.
Yeah,
He
up
didn't show
2022.
up other
Yeah,
data out of 2022.
Yeah, we stopped in 2022. Yes.
There was another question here.
To make link predictions, do you use also edge attributes? Because from your presentation, I think that you use only node attributes to make the embeddings, right?
Yes. Yes, only know the attributes.
And the next question is, how do you infer the link? Do you use any, what kind of similarity function do you use to relate these embeddings?
Good question. I don't remember. I need to get my notations. I will ask you after about this, all right?
So, if there are no other questions, let us thank again the speaker.
Thank you. Thank you very much.
By the way, in 1 minute maximum, we will go to the coffee.